Hey guys, welcome back to our Python programming series. In this episode, we'll go ahead and continue our discussion on classes and objects. In the part one, we kind of went through the classes, how do we work with the attributes, how do we create an instance of a class, and we went ahead and looked how do we create a methods, how do we call the methods, and some of the things. We'll go ahead and take a look at another important concept of the object-oriented programming. It's called inheritance. So inheritance is one of the core concepts of any object-oriented programming language, not just the Python. Any object-oriented programming that you work, there is a concept of inheritance. Inheritance is just simply a mechanism where we can derive a class from another class that share a set of attributes and methods. So simply, let's say you have a class A, and within the class A you had certain attributes and certain methods. Using that class A, you can go ahead and create another class, let's say class B. And when we create a class B, I can say, okay, hey, I am deriving my class B from class A. That means the class B would automatically have all the properties, that means all the attributes and all the methods of class A. And now within class B, you can go ahead and create some more attributes, some more methods if you like, or you can just simply use all the methods and attribute from class A itself. So in this case, we will go ahead and take a look. There is something called base class and there is something called derived class. And now let's take a look at some of these things via an example. So we'll go ahead and create our base class first. So in this case, I'm creating a base class, and the name of the base class that I'm creating, I'm calling it an employee class. So let's go ahead and create a class. We'll go ahead and call the class as employee. And now once we have defined or declared our class, again we would go ahead and define our special method init, which will call when it gets executed when we create an instance of this class. So let's go ahead and define that. So using the def keyword underscore underscore two underscores and init underscore underscore, and I'm just passing the self keyword. This time we're not passing any parameters. Again, it's optional. If you want, we can go ahead and do that. And I'm just making use of a simple print statement that would say, okay, hey, employee class instance creation successful. So we would just simply go ahead and said, okay, hey, when somebody creates an instance of this class, just simply go ahead and print this message that says, okay, employee class instance creation successful. And that's what we are doing. Now let's go ahead and create one more method within this class. Again, we would make use of a def keyword, and let's call it again list underscore employees. And again, it would make use of the self keyword. We're not doing anything, just simply again a print message, list of all the employees. So what we just did here, we just created a class, and the name of the class in this case again is employee. Within the employee class, we are making use of our special method init, and then we went ahead and created one of our own custom method, and the name of that custom method is list employees. So this would serve as our base class. Now just to test this one quickly, we can always again go ahead and create an instance of this class. So let's go ahead and create an instance. We are calling emp1, and it's of type employee. Now if you want to just confirm anything, we can just go ahead and simply say, hey, print emp1. We're not interested in, let's say, type, just simply call the method. So now we can say emp1 dot list employee, and now let's just go ahead and execute this program. And at this stage, you can see we have two print statement being printed. Why? Because when we create an instance, this init method was called automatically, and because of that, the first print statement employee class instance creation successful, we see this one. And in the second line, we are specifically calling the list employees method. So we are saying emp1 dot list employees. And because of that, we do see this second line, list of all the employees message being printed. Now using this class, now let me just go ahead and remove these two lines for now. Now we will go ahead and derive a new class from this employee class. So now let's go ahead and create a new class, and that class would call your inherited class. So now let's go ahead and we are creating another class, and the name of that class we are calling is the IT department. So now let's go ahead and create another class using the same class keyword and give it a name for your class. So in this case, I'll say employee department. And now within these parentheses, we can go ahead and pass the name of our base class. So in this case, the base class is employee. And as you can see, when I'm typing, IntelliJ is presenting me, okay, that's what you're interested in probably. So now let's go ahead and select that. So what we just did with this line, we went ahead and created a new class. But when we are creating a new class, we went ahead and passed our employee class as a parameter to this class. That means we are inheriting, we are driving, or basically we are inheriting all the methods and all the attributes of the employee class into our IT department class. So now the IT department class is your inherited class. Now within this class, we can have our own special init method, or we can have some of the other methods that you want to go ahead and. So now let's go ahead and define our first special init method. So that means if any time any instance of this class gets created, we want to call our init method. So now within this init method, what we want to do, now within this init method, we can go ahead and do anything. And one of the things we can do, okay, we know, okay, hey, we are driving IT department from employee. That means we have access to all of these things. So now when somebody is creating an instance of this class, let's go ahead and call the init method of our employee or the base class also. For that, now let's go ahead and type the name of the class. The name of the class is employee. So we are saying, okay, hey, I'm calling the employee class, which is my base class. And within that, now when I do a dot, hey, there are a couple of methods within that class. There's a list employee method within the employee. There is a init underscore underscore self. As you can see here, the name, it says employee. That means within the employee class, there are two methods. One is our special method, the init method, and another was a list employee. So which method are you interested in calling? So I'm saying, okay, when I'm calling the init method of my IT department class, I want to call the init method of the employee class also at the same time. And now we will go ahead and pass again the self keyword here. So we'll just go ahead and call it self. And that's how we are creating the instance of an employee class. In this line, we are creating an instance of the employee class. Now, if we need to do any further thing, we can just go ahead and type that. You know, just simply say, okay, we can say, okay, hey, instance of IT department created. So we are just printing some message again. Just to test it quickly, I can go ahead and create an instance of the IT department class. So now let's go ahead and call it IT employee 1. And the IT employee 1 is an instance of the IT department class. And now within this class, we are not passing anything. So I'm good to go ahead at this time. Now, because the IT department class is the derived class from the base employee class. So that means the IT emp1 instance can access this init method as well as this init method as well as this list employees method. And just to prove that, now just simply go ahead and type the name of your instance, IT emp1. And when I do a dot, you can see we are being presented with a couple of things. It says, okay, hey, within the IT department class, we have this init method. If you are you interested in accessing that? Or within the employee class, we have this list employee method also. Are you interested in accessing that one? So now let's just go ahead and try to access this particular method. So, and we are calling this method on the IT employee 1. The IT employee 1 is an instance of the IT department class. So now let's see when we go ahead and run this program, what happens. And you can see there are 3 print statements. So let's go line by line. So here, when we create an instance of the IT department, we know when an instance gets created, the special method init gets called. So now we come inside this init method. So within the init method, the first line says employee.init self. That means, hey, we are calling or we are creating an instance of the employee class and we are calling the init method of that class. So now if I go back to the init method of the employee class, which says that the only thing it says employee class instance creation sections full, and that's the reason we see this first line being created. Now once we are done, now we come to this line where this line says, okay, hey, instance of IT department created. And that's the reason you see this second print line says instance of IT department created. So that is happening because of this line number 14, because 14 is just trying to call this init method, which eventually calls the init method of the employee class. And once that is done, we continue with the rest of the statement within this init method of the IT department. And once that is done, now we are calling on this particular instance, the list of employee method, which is again inside the employee class. So we go back inside the employee class, we go ahead and execute this line of code. And after there is nothing, we just come out. So that's how we can see, we can go ahead and create or we can go ahead and derive a new class from one of the existing class. So the existing class will call the base class, and the new class will call your derived class. Another good thing, now within this class we can go ahead and create more methods, more attributes if we really desire. There may be a situation where IT department can also have its own method by name of list employee. So if you end up creating a same method where the name of the method is same as your base class method name, that means we are overriding. That means when I'm calling this list of employee, I'm really interested in accessing the local list of employee instead of the one from the base class. And what I mean by that, let's go ahead and quickly demonstrate that. So let's go ahead and create a method, and we call the method again as list of employees. And now within that, I'll say we are IT department employees. Now let's see, I'm not changing anything else. Now let's go ahead and rerun this program and see what happens. And again, when we created an instance, init method was called. Within this employee init was called, and because of that we went ahead and we ended up printing this line, and then we continued the execution for the second line. That's the reason you see. Now we went ahead and called list employees, and you can see now we have this list employee method within the IT department class as well as inside our base class. When we have the same method in our base class as well as in the derived class, in that case the overload happens and overriding. We are basically saying, okay, hey, we are creating a method of the same name. That means if I'm trying to access this one, list employees, that means I'm trying to access the list employee which is inside the IT department one. And that's how we can go ahead and override certain methods and certain things that we probably need. Now let's go ahead and take a look at some of these special methods or functions. Sometimes they're called the magic methods also. At this stage, if I go ahead and try something like this, let's leave some of these things. If I try to maybe do, okay, hey, print, I'm interested in finding the length of, let's say, IT employee 1, and see what happens when I'm trying to execute. We being presented with an error automatically where it says, okay, hey, type error, object of type IT department has no length. It clearly indicates, okay, hey, your IT department, which is our class, and of that class we have this particular instance, says there is no such object as a length. If we don't have a length, let's try something else. Can we go ahead and delete this IT employee? Can I call a del method like what we had done earlier on our list or something? Now let's go ahead and execute. And it says, okay, process finished with execute 0, but we really don't know if anything really happened or not. If I try to do print of IT employee 1, see what happens. We are just being presented with an object, but not really some of the other things, because if you recall, if I go ahead and create a variable, let's say if I go ahead and create a variable and I call x is equals to hello, and if I do a print on x and execute at this stage, we are being presented with this string. So these are some of the use case where we can go ahead and make use of these special methods or magic methods. Like when we saw the case when we tried calling a len, it said, okay, hey, there is no such function length is available for your IT department. And again, we can try some of the things. So that's where these magic methods really comes into the handy. So when we call a print on some variable, we are being returned the string representation. So we can go ahead and define the similar string representation of our class. So what I mean, so let's go ahead and quickly take, use with the help of an example. So now let's go ahead and leave some of the things. Now we'll go ahead and define our special methods, and I can go ahead and use the def underscore underscore. And as you can see, within this list, IntelliJ has a couple of things that is being presented. And now let's try, we'll call the special method string on that one. And within this string method, we have to use the return statement. And within the return statement, I can go ahead and simply print any message that you want. And I'll say, okay, this is my probably the IT department class. And now if at this stage, if I try doing a print on, let's see what happened when we do it now, print on IT employee 1. As you can see, now last time we were being presented with an object. Now we are being presented with a message, IT department class. So this is the string representation for your class. So we can go ahead and print any message when somebody trying to do a print on the object. We can go ahead and print a specific message that way they know, okay, hey, they're working with a class, so we cannot have a regular some of those things. Similar way, if you want to have a certain length for your class, we can go ahead and make use of the special method, which is your length method. Again, in the length method, I can go ahead and say return length of my object. I can probably say 1, and now any more. So now let's try go ahead and executing this program. And in this case, we are being presented when we are doing a length on ITMP, it says the length is 1. So there are many more, some of these special methods or the magic methods that we can go ahead and define for our class. We just took a look of the string representation. We went ahead and configured the length. We can just similarly do the delete and some of the other things that we can call on our class. That'll be all for this episode and for our classes and object. And I just want to emphasize the class as an object is very important concept when you are working with Python or any other programming language, and especially the object-oriented nature. So do spend good amount of time creating different type of class, creating multiple instance of the class, driving the classes, and calling some of the methods, doing an override, defining some of the special methods and all. That'll be all for this episode. I will see you guys in the next episode. Thank you.